Hello everyone, welcome to math class. For today, we are going to discuss about the derivatives of inverse hyperbolic functions. So what is inverse hyperbolic functions? Inverse hyperbolic functions are the inverses of the hyperbolic functions sine x, cosine x, tangent x, cotangent x, secant x, and cosecant x. For now, let's proceed to the inverse hyperbolic table. First is the inverse hyperbolic function of sine x, and its derivative is 1 over square root of x squared plus 1, and it has no restriction. Second is the inverse hyperbolic function of cosine, and its derivative is 1 over square root of x squared minus 1, and its restriction is any variable should be greater than 1. And for the inverse hyperbolic function of tan x, and its derivative is 1 over 1 minus x squared, and for the restriction is the absolute value or non-negative value of x is less than 1. For the inverse hyperbolic function of cosecant, is its derivative is negative 1 over absolute value of x square root of x squared plus 1, and its restriction is that x is not equal to 0. The derivative of inverse hyperbolic function of secant is negative 1 over x square root of 1 minus x squared, and its restriction is x is greater than 0 but less than 1. And lastly, for the derivative of inverse hyperbolic function of cotangent is 1 over 1 minus x squared, and its restriction is the absolute value of x is less than 1. And now let's proceed to the sample problems. Example number 1. The derivative of the inverse hyperbolic function of sine x, and the formula for this is 1 over square root of x squared plus 1. And then let's substitute x into the formula, which is the 1 over square root of x squared plus 1. So for the x, for example, is 3. We can calculate this as 1 over square root of 3 to the power of 2 plus 1 is equal to, copy the 1, and for the 3 raised to 2 is 9, and just copy the 1, and it will be equal to 1 over square root of 10, and when you convert it to decimal, it will be 0.316. And now let's proceed to example number 2. It has the same concept with the example number 1, but with different value of x. So now let's substitute the formula with 7, and it will be 1 over square root of 7 raised to 2 plus 1, and just copy the 1, and the 7 raised to 2 is 49, and of course copy the 1, and it will be 1 over square root of 50, and if you will convert it into decimal, it will be 0.141. Now let's proceed to the chain rule with the inverse hyperbolic of sine. Now let's find the derivative of inverse hyperbolic of sine 2x. First, you need to recognize that the outer function of inverse hyperbolic of sine where u is equal to 2x. Next is the derivative of the inverse hyperbolic of sine with respect to u is 1 over square root of u raised to 2 plus 1. And then differentiate the inner function, which is u is equal to 2x with respect to x. After that, you can use the chain rule, which is 1 over square root of 2x squared plus 1 times 2 is equal to 2 over square root of 4x squared plus 1. And then the example calculation, let's find the f of 1 equals 1 over square root of 4 times 1 raised to 2 plus 1 is equal to 2 over square root of 4 plus 1 is equal to 2 over square root of 4 plus 1 is equal to 2 over square root of 5, and when you convert it to decimal, it will be 0.8444. Now let's proceed to the next example. Find the derivative of inverse hyperbolic function of sine 4x. The outer function is the inverse hyperbolic function sine u, where u is equal to 4x. The derivative of inverse hyperbolic function of sine u with respect to u is 1 over square root of u raised to 2 plus 1. And the inner function u equals 4x with respect to x is 4. And using the chain rule, f of x equals 1 over square root of 4x raised to 2 plus 1 times 4 is equals to 4 over square root of 16 raised to 2 plus 1. Example calculation. Let's find f of 2 equals 1 over square root of 16 times 2 raised to 2 plus 1 is equal to, just copy the 1, and over square root of 16 times 4 plus 1, you get the 4 by simply multiplying 2 times 2 and just copy the 1. And it will be equal to 1 over square root of 64 plus 1 equals 1 over 65. And when you convert it to decimal, it will be 0.1240. Now let's proceed to the inverse hyperbolic function of cosine x, which is 1 over square root of x squared minus 1. For number 1, just apply the formula directly and substitute the x into the formula, which is the x is 5. So 1 over square root of 5 squared minus 1 is equal to, just copy the 1 over square root of 25 minus 1. You get 25 when you multiply the 5 itself. And 25 minus 1 is equal to 24, so it will be 1 over square root of 24, it will be equal to 1 over 2 square root of 6, and when you convert it into decimal, it will be 0.204. Now let's proceed to number 2, example calculation. Let's find the g of 7. So it's the same with the number 1 example but with different value. So 1 over square root of x squared minus 1 is the formula, and substitute the 7. So it will be 1 over square root of 7 raised to 2 minus 1 and equals 1 over square root of 49 minus 1. You get 49 by multiplying the 7 itself, and 49 minus 1 is 48, so it will be 1 over square root of 48 is 1 over 4 square root of 3, and when you convert it into decimal, it will be 0.144. And now let's go to the chain rule of the inverse hyperbolic function of cosine. The given problem is inverse hyperbolic function of cosine 5x squared. Let key x equals inverse hyperbolic function of cos 5x squared. First, you need to identify the inner and outer function. The outer function is the inverse hyperbolic function of cosine u, where u equals 5x squared. Second, you need to differentiate the outer function. The derivative of inverse hyperbolic function of cosine with respect to u is 1 over square root of u squared minus 1. Then, differentiate the inner function. The derivative of u equals 5x squared with respect to x is 10x. Lastly, you can apply the chain rule. 1 over square root of 5x squared raised to 2 minus 1 times 10 is equal to 10x over square root of 25x raised to 4 minus 1. So now let's proceed to the example calculation. Let's find key of 1. So you need to substitute 1 to the variable, and it will be 10 times 1 over square root of 25 times 1 raised to 4 minus 1, and it will be equal to 10 over square root of 25 minus 1 equals 10 over square root of 24, and it will be 10 over 2 square root of 6 equals 5 over square root of 6, and when you convert it to decimal, it will be 2.041. Let's proceed to the next problem, which is the inverse hyperbolic function of cosine 8x squared. Let key of x equals inverse hyperbolic function of cos 8x squared. Find the outer function, which is the inverse hyperbolic function of cosine u, where u is equals to 8x squared. The derivative of inverse hyperbolic function of cosine with respect to u is 1 over square root of u squared minus 1. And to the inner function, the derivative of u, which is the 8x squared with respect to x, is equal to 16x. And now let's apply the chain rule. Q of x is equal to 1 over square root of 8x squared raised to 2 minus 1 times 16 is equal to 16x over square root of 64x raised to 4 minus 1. You get the 64 by multiplying the 8 by itself. And for the example calculation, let's find Q of 3 is equal to 16 times 3 over square root of 64 times 3 raised to 4 minus 1 is equal to 48 over square root of 64 times 81 minus 1. It is equal to 48 over square root of 5,184 minus 1, and it is equal to 48 over square root of 5,183, and when you convert it into decimal, it will be 71.993. And now let's proceed to the derivative of h of x is equal to inverse hyperbolic function of tan x, and the derivative formula for inverse hyperbolic tan x is 1 over 1 minus x squared. So first, you need to recognize the formula and then substitute the x into the formula. And now let's substitute the x into the formula, which is 0.5. So 1 over 1 minus 0.5 raised to 2 is equal to 1 over 1 minus 0.25. It is equal to 1 over 0.75, and when you convert it into fraction, it will be 4/3, and when you convert it into decimal, it will be 1.333. And for the next example, let x is equal to 0.9. So let's substitute the 0.9 into the formula. 1 over 1 minus 0.9 raised to 2, it will be 1 over 1 minus 0.81. It will be 1 minus 0.19, and when you convert it into decimal, it will be 5.263. Now let's proceed to the chain rule of the inverse hyperbolic tangent. So find the derivative of g of x is equal to inverse hyperbolic tangent 3x. And first, you need to identify the outer function. Inverse hyperbolic tangent of u, where u is equal to 3x, and then the derivative of inverse hyperbolic tangent u with respect to u is 1 over 1 minus u squared. And now let's differentiate the inner function, which is the u is equal to 3x. With respect to x, it is equal to 3. And now we can use the chain rule. 1 over 1 minus 3x squared times 3 is equal to 3 over 1 minus 9x squared. And now let's proceed to the example computation. 3 over 1 minus 9 times 0.1 raised to 2 is equal to 3 over 1 minus 0.9 is equal to 3 over 0.91, and when you convert it into decimal, it will be 3.297. And that ends our discussion. Thank you for watching.